Yeah, we are live and good to go.
Yeah, okay. Thank you very much. Namaste. Good morning and good evening to one and all. I, Shri Kulkarni, welcome you all for inaugural function of Joint Chapter AP, MTT and EMC Society's IEEE Pune section.
Namaste. I, Priya of the Joint Section, welcome you all for today's event. Hope you all are safe and healthy. We start today's event in the traditional Indian way by invoking Lord Ganesha and seeking his blessings for the successful conduct of proceedings.
Now may I request Professor G.S. Mani, Chair, Joint Chapter Pune, to give his welcome address. Please, sir.
Oh, thank you. Thank you, Dr. Jayashree. We had the virtual blessings of Lord Ganesha. And now we start off. Good morning, good afternoon, good evening, depending upon which part of the globe you are. I hope I am audible.
Yes.
So in our Indian way, let me say Namaste. Namaste is cuts across all time barriers, whether it's good morning, evening, or afternoon. So Namaste is a best way of greeting. So Namaste to all of you. We are privileged to have many dignitaries among us today. Dr. Y. Antar, President AP Society, Dr. Alistair Duffy, President EMC Society, Dr. Henderson, President-elect 22 MTT-S, Dr. Martha Mogadam, past President APS, Dr. Goutam Chattopadhyay, Senior Scientist from NASA, Dr. Deepak Mathur, Director R10, Dr. Girish Khilari, Chair Pune Section, Dr. Ajay Poddar, Chair APS CAC, Dr. Jagdish Sidhiki, APS R10 Coordinator, Dr. Anisha Apte, Editor APS Copay Column. Hearty welcome to all of you, sir. We are extremely privileged to have all of you, ladies and gentlemen, on this evening, though of course virtual. We sincerely wish your physical presence in the near future. We have many other distinguished guests here. Dr. Surendra Pal, Dr. Madhukar Pitke, Dr. Shiban Kaul, Dr. Suresh Nair, Dr. Pramod Kale, Dr. Anant Krishnan, Dr. Yashwant Gupta, Dr. Ramanayan. Welcome to all of you, sir, and also other guests who have taken their valuable time off to be with us on this day. Thanks a lot for accepting our invitation. My dear colleagues from IEEE Pune Section Executive members, my fellow officers of AP, MTT, and EMC societies from different parts of the country, my dear students, IEEE volunteers, and Eureka participants, and also school teachers. We have invited quite a few school teachers who have been kind enough to respond to our invitation to be here today. Hearty welcome to all of you. The newly formed chapter, joint chapter of AP, MTT, and EMC under the aegis of IEEE Pune section looks forward for your help, guidance, and coordination to grow up. Today, we are probably going to witness a unique event in the history of IEEE. I say it's unique because presidents of different societies, IEEE societies are coming together. Present president, past president, and future presidents also are coming together. It's also unique in a way because all of us are going to inaugurate the function by traditionally lighting the lamp, and traditional in the Indian way, and also in virtual mode. I think it's going to be unique event. Probably unique in the history of IEEE. So with this, for this to happen, many people have encouraged us, have helped us to make this happen. Let me just say simply a big thank you for all of you. Thank you very, very, very much. With that, I once again welcome all of you and hand over the mic to the comparers to take the program forward. Thank you very much. Thank you, Priya.
Thank you, sir. The joint chapter of AP, MTT, and EMC was approved on 20th August 2021. Immediately following that, we had a meeting in which the following office bearers were elected: Professor G.S. Mani as chair, Professor K.P. Ray as co-chair, Dr. Y. Ravinder as vice chair, Dr. Shri Kulkarni as vice chair, Mr. Pritish Rathod as secretary, and Mr. Nikhil Grover as treasurer. May I now request Professor Ray, co-chair of the Joint Society, to welcome our honored guest.
Thank you, Priya. Namaste and very hearty greetings from the city of Pune. We are really fortunate to have a host of dignitaries both from abroad and India. Today is an auspicious day for all of us for two counts. Firstly, it is the second last day for the 10-day long Ganpati festival, which is the most important festival in the city of Pune. And secondly, the inauguration of IEEE APS, MTT-S, and EMC Society Joint Chapter at Pune is happening today, which was long overdue. I say long overdue because Pune has more than a dozen government institutes, laboratories, where antennas, electromagnetics, microwave, and EMI/EMC activities are carried out. It also has a large number of engineering colleges and institutes and very prestigious universities such as Savitribai Phule Pune University, Defense Institute of Advanced Technology, that is known as DIAT, which is fully funded by Ministry of Defense. Also, Pune has distinction of having large number of industries wherein activities are related to field of this joint chapter. So as a member of IEEE, we all are connected to the world's largest technical platform. And this joint chapter at Pune will further facilitate a fruitful interaction of each IEEEan with experts and renowned personnel at international levels. For all of us, particularly for youngsters and students, it will be very enriching and rewarding experience. Encouraged by the enthusiasm shown by each and every members, we plan to double the membership of this chapter in very short span of time. Once again, I welcome all the dignitaries and each and every participants of this inaugural function. Looking forward to very close interactions. I thank you all. Thank you.
Thanks a lot, sir, for welcoming everyone.
Now it's my pleasure to welcome our today's chief guest. Dr. Deepak Mathur is the director of IEEE Asia Pacific region and is also one of the most energetic person. Having a long track record as an IEEE volunteer, serving in various capacities over the last 2 decades, he is extremely popular among all IEEE members in Pune. Shri Girish Khilari is the chair, IEEE Pune section, and has been the guiding spirit behind all our activities. We consider it our privilege to request him to Shri Deepak Mathur and Shri Girish Khilari to inaugurate the joint chapter. Please, sir.
Thank you, Dr. Jayashree.
Thank you, Deepak sir and
Sir, just 1 minute. Sir, just 1 minute.
So congratulations,
Sir,
Girish, Khilari ji
one more minute, sir.
and GS
Sir,
Money.
one more minute.
Yeah, okay.
Yeah, sure.
Now I request Shri Deepak Mathur to share his views on this auspicious occasion. Please, sir, over to you, sir.
So many congratulations to Pune section for inauguration of this chapter. Thank you, Priya, and thank you, Dr. Shri, and thank you, Professor KP Ray, and many thanks to Professor GS Money for kind invitation and giving me this honor. And it's really my pleasure and great honor to be part of today's inaugural ceremony of formation of IEEE Pune section's joint society chapter of AP, MTT, and EMC societies. So all distinguished guests and today's speaker, Dr. Goutam Chattopadhyay, and my IEEE colleagues, ladies and gentlemen, namaste. And many congratulations to each one of you at Pune section who are involved in the formation of this chapter. And my special thanks to Professor J.S. Money for your leadership and initiative. In fact, it is a well thought initiative to form a joint chapter to keep members gainfully engaged and bringing the various benefits offered by these societies to members. As we know that a chapter also provides an opportunity of networking and brings many leadership positions which our volunteers would be serving. So this is a great member engagement and great volunteer engagement through this formation. Let me share a little about Region 10. Region 10 is largest, fast-growing and diverse region. We have 60 sections, 6 geographic councils, and 42 subsections. So we are still growing. Many of our subsections have potential to become full section in near future. So we have close to 800 chapters and approximately 1300 student branch chapters. And one of our thrust area for 2021 and 2022 is section chapter collaborative programs. At Region 10, we strongly believe collaboration is key to success. And I'm sure newly formed joint chapter of AP, MTT, and EMC shall also be collaborating with section in organizing member-centric programs. So let our programs create value to address member recruitment and member retention. That is what only way we can get the sustainable membership growth. So with this, I would like to congratulate once again all at Pune section. And before I conclude once again, thank you for your initiative and many congratulations for formation of new joint chapter at Pune section. And I wish you all the best. Thank you very much.
Thank you, sir, for your kind words. Thank you. Now I request Shri Girish Khilari to share his views. Please, sir, over to you.
Yeah, thank you very much. And good evening to all the dignitaries from IEEE, both from Pune, from rest of the country and from abroad. So my sincere thanks to each one of you for being present today for this inaugural function. So it gives me immense pleasure to inaugurate the joint chapter for the societies, as Mathur sir and Mani sir mentioned, AP, EMC and MTT. This indeed a proud moment for IEEE Pune section. As Mathur sir mentioned, that this will create a lot of leadership opportunities, because there are 3 societies are coming together and forming this joint chapter. And as a chair Pune section, I definitely will help on every activity that this newly formed chapter will be performing rest of the year and then time to come. And my sincere request to all the joint chapter leaders is that very soon we really would these 3 separate chapters under Pune section. This will not only help us growing the membership, but it will also, as Mathur sir mentioned, will create opportunities, leadership opportunities, networking opportunities, And then there are various, as KP Racer mentioned, that there are so many research institutes in and around Pune. Industries are there which are related to both all these chapters, AP, EMC, and MTT. So those industries will also get benefited. Plus, we have so many engineering students. Okay, Pune has over 100 educational institutes and more than 9 deemed universities, apart from Savitribai Phule University, as Racer rightly mentioned. So this is a big opportunities, not only for researchers, but for educational institutes to work together jointly and make the difference for the city of Pune. So I once again congratulate to all the 3 societies to forming this joint chapter, and very soon I would like to see all of them run separately. So my sincere and wishes to each one of you. Thank you very much. Back to you, Madam, Shri Madam. Thank you.
Yes, sir. Yeah, sir, many thanks. Your message is very encouraging and we look forward to your continued support in future. Thank you, sir.
Thank you.
In our Indian tradition, we start an event by lighting a lamp. Light is a symbolic of the guiding spirit, and we believe the lamp will provide enlightenment and guide us in our path to prosperity. May I now request all the dignitaries and honorable guests to light the lamps. Thank you so much. Indeed, it is a historic moment. Probably this is the first time in the history of IEEE, presidents of 3 IEEE societies are coming together to inaugurate a joint chapter while lighting a lamp virtually. Sure, history will remember this event.
Dr. Antar is the fellow of IEEE, Engineering Institute of Canada, the Electromagnetic Academy, and the International Union of Radio Science. He has won many distinguished awards and held many prestigious posts in IEEE, URSI, and Canadian Defense Advisory Board. Dr. Antar is the president of IEEE AP section. May I now request Dr. Antar to give his message for all of us. Please, sir. Over to you, sir.
Good evening. This is wonderful. This is a historic event. First of all, I would like to thank all of you. I'd like to thank Professor Maria and Professor Ray and the rest of our colleagues in Pune. And I would, like to thank Alistair, Duffy, and Shwanda, my colleagues from IEEE. And I would thank Ajay Podar that started helping the whole thing. The warmth of this ceremony here really makes me feel like I am in India again. I've been to India. I have seen the warm welcome, the warmth they offer visitors and so on. So this is wonderful. I thank all of my Indian colleagues in IEEE and so on, and thank everybody for giving me this opportunity. I'm honored to address you on behalf of the Antennas and Propagation Society. You in India form at least 1/3 of the members in Region 10. So you have over 1,000 members in Antennas and Propagation Society. Obviously, with combination with EMC and MTT, you really started a very, very good and vibrant effort that will really reflect on the membership, reflect on the young guys, and provide a good start for future activities in such a vibrant city, as you mentioned, and as was mentioned by my friends before. You have many universities, you have many institutions, you have many vibrant members, and the societies, all IEEE societies have benefited in the past from some of the efforts of many of your members, and will continue to do that. So congratulations, and I hope we'll be able to visit in person and feel the Indian welcome. And looking at lightening the flame here, I hope this will radiate more and more energy and so on. And again, thank you all. And I welcome my colleagues from North America and my colleagues in India. And on behalf of the society, we look forward to really working with you and initiating all activities, and for you to benefit from the IEEE and enrich our society and our societies in all aspects. So thank you all. This is wonderful. This is great, and we look forward to to more activities as the chapter develops. Thank you all.
Thank you, sir. We look forward to your visit to India. Thank you, sir.
Thank you.
Alistair P. Duffy did his PhD at Nottingham University, UK. He has specialized in the field of computational electromagnetics and is currently director of the Institute of Engineering Sciences. He is also professor in electromagnetics at De Montfort University, Leicester, UK. Dr. Duffy is a fellow of the IEEE and of the Institution of Engineering and Technology, that is IET. He is the president of the IEEE EMC Society. May I now request Dr. Duffy to give his message. Over to you, sir.
Namaste. Thank you very much for this invitation, and congratulations for bringing this chapter into existence. I could wholeheartedly endorse Professor Antar's sentiments and the content there. It's an honour to be part of this inauguration. And as with APS, the EMC Society looks forward to supporting all your energy and your ideas. And with Pune being a renowned centre for IT and manufacturing, and with the excellent higher education and research institutes, you're well placed to be a jewel in all our crowns. So very briefly, just thank you for your invitation. And I look forward to seeing you all in person as soon as we possibly can travel. So thank you very much.
Thanks a lot, sir. We look forward to your continued support in the near future.
Rashunda Henderson did her PhD at the University of Michigan and was with Freescale Semiconductor, formerly known as a Motorola. She is a professor at the University of Texas at Dallas. She has been investigating novel passive components and integration techniques for millimeter wave circuits and systems operating up to 300 gigahertz. She is also known for her work with young women, supporting their efforts to pursue STEM fields as a career choice. Dr. Henderson is the IEEE MTT-S President-elect 2022. May I now request Dr. Henderson to give her message. Please, ma'am, over to you, ma'am.
Good morning. Good morning here in the U.S., but good evening, good afternoon everywhere else. And I'm so excited to be here. I also agree with the sentiments that have been given by the two presidents, and I am representing President Greg Lyons, who couldn't be here today, or I keep wanting to say this morning, but this morning, this afternoon, and this evening. But we also are very excited about this new combination of societies coming together. And as I was thinking about what I would share today, I remember when I moved to Phoenix, I was part of Waves and Devices, which was actually 5 different societies combined. So I understand how it is the synergy that comes from multiple societies coming together and sharing their knowledge So this is a very exciting opportunity for the Pune section. And one of the things that I want to make mention of is the joint chapters that MTT is affiliated with. We have 87 joint chapters within the 9 regions, and 74 of those are with APS and 15 are with the EMC. But as we move forward, we're going to, as this is an example of one of those where we have both APS and EMC-S. So we're very excited about that. Another thing to consider is just the activity that goes along with inter-society efforts. And Kay Wu, who is a past president of the society, is actually the chair of the Inter-Society Committee. And so he's really working on different activities to bring different societies together so that we can benefit from our strengths and also work towards using each other to develop around our weaknesses. One other thing to mention is the efforts towards the young professionals. One of the initiatives Greg had this year was to give young professionals a voice within the AdCom. So he appointed 3 young professionals on the AdCom, and I'm going to continue that in 2022. And so there's a lot of energy that's being placed around listening to the needs and the concerns of our young professional constituents, excuse me, within the society. So they have activities. We have, excuse me, representatives from all 9 regions, or I'm sorry, all 10 regions. And so we just look forward to the opportunity when we can come back to India and participate in activities like MTT-S, IMARC, but we know that AP and EMC have the conferences in that region. And so we just look forward to being able to partner together and to take advantage of the synergy that exists. So I'd like to wrap up once again by just congratulating you on this great achievement of bringing everyone together. And we look forward to the great results that are going to come forth, whether it's at the professional level, academic level with the students, young professionals, and even as was mentioned earlier, passing that on to students, young students. And so having the teachers here so that they can understand what goes on within IEEE is extremely important. So thank you and congratulations.
Thank you, ma'am, for your kind words. Thank you.
Now we come to our mentor who has been guiding us at every step towards informing our joint chapter, Dr. Ajay K. Poddar. Hailing from Pune, Dr. Poddar got his postgraduate degree from IIT Delhi, doctoral and postdoctoral degree from Germany. He is a chief scientist at Synergy Microwave, New Jersey, USA, and is responsible for the design and development of signal generation and signal processing electronics for industrial, medical, and space applications. Dr. Poddar is associated with AP and MTT societies in many ways. ADCOM member of IEEE MTT-S, MTT-S Site Committee member, chair of IEEE HSC Committee, Partnership Engagement Working Group, chair of IEEE APS Chapter Activity Committee, and chair of IEEE North Jersey section. Just few names to go. Dr. Puta, you have given the guidance informing the joint chapter. May I now request you to give your message to the newly formed chapter. Over to you, sir.
Thank you for the great introduction. Greetings to all the dignitary IEEE volunteers and members, especially IEEE Pune section members. My heartfelt thanks to IEEE Pune section leadership for invitation to attend the joint AP MTT EMC Pune chapter inauguration event today. I am very much familiar with all the society presidents. They have a lot of cooperation from Professor Antar and Dr. Greg Land, Rasunda, and Dr. Duffy. All are very cooperative. I'm working as a scientist for the last 21 years at Synergy Microwave Corporation. But prior to coming to New Jersey, I have worked for 10 years at ARD Pasan, Pune. The good memories of working with DRDO scientists, especially ARD and DRDL, DMRL scientists, are still fresh in my mind. And Professor Mani was at the time was IIT director. We have a lot of personal, friendship issue and guidance from him. So Pune is well known for the defense research laboratory, electronic industry, and reputed academic institution with large number of professionals in the area of microwave and wireless communications, antenna, radio astronomy, information technology, medical electronics, name the things, it's there. Past history has revealed that technology improves the standards of living, progresses the quality of life, and stimulates coordination and agreement. But advancing technology also has a possibility to destroy our planet Earth if not used appropriately. This kind of discussion, I always had Dr. Goutam Chattopadhyay and Professor Antar, many like-minded people, to Dr. Sidhiki and Ifafte, how to involve ourselves in IEEE platform to reach to outreach community. IEEE provides a roadmap that enables professional volunteering forces to work together to arrive at a sustainable approach for advancing technology to make our planet a better place to live in for all of us. And that's why we are here today. Everybody having like a lot of busy schedules, so their time and resources, they're spending their own time and resources and leaving family behind and working for this good cause. The Institute at IEEE, diversity is an important and valued strength. IEEE is committed to advancing diversity in the technical profession and to promote an inclusive and equitable culture that welcomes, engages, and rewards all, irrespective of races, religion, gender, disability, age, and national origin. No other society, because IEEE doesn't have geographical boundary. You can share about know-how, knowledge, expertise, all the things. It was a long-term dream of IEEE Pune section members to form joint chapter with AP, MTT, EMC-S for the benefit of local members and professional community. I remember during the days, my 1980s and 1990, when you go for IEEE journal publication, it was so much delayed. And I want to thank our late president and SA2RM, Dr. Abdul Kalam. He was main guide factor to join our IEEE. From that time, we joined as IEEE as a valued things our professional lives. Partnership with sister society, industry, academic institution, and local community will strengthen definitely the society and promote equality in underserved community. Now, chapter is 4, which is good thing. And I request chapter officer to plan the agenda for the remaining part of the year and future roadmap. I'll always be in communication to how to move forward. APS President, Professor Antar, I have the greatest respect for him. Very, very supportive. He has started this year several initiatives, which is APS Scope, it's called Committee on Promoting Equality. He has funded generously APS Smart Village and APS YP program. All these programs will go jointly, MTT Society also, EMC Society also, because they're very cooperative. And this initiative facilitates additional financial support to local chapters for providing online education materials, computers. Many schools doesn't have internet connections, books and scholarship for underprivileged students, community and mentorship for higher education. And my team, like Dr. Sidhiki, Dr. Apte, Professor Antar, Professor Venture, we're talking to Professor Mani and team how to reach to outreach program, not only in Pune and other part of India also. Currently, I'm serving actively as ADCOM member, voting member for MTT in AP Society, as a member of MJ Committee, Inter-Society and Site. You can reach me for chapter-related financial support matters by email, by phone. Many of you are new. I assure you will receive response immediately, in most cases not later than 24 hours. I want to thank IEEE Pune section once again and chapter officer for continued support of our shared mission to advance technology for humanity. And many things you will listen from Dr. Goutam Chattopadhyay, how he correlates whenever he gives the talk, even is a NASA scientist, but he correlates humanity as a main important factor for the IEEE. And I wish you all the success and continue to stay safe and healthy. Thank you very much.
Thanks a lot, sir. We look forward for your continued support in the near future.
Thank you.
Dr. Sidhiki has been our good friend guiding us in our journey. An alumnus of Institute of Radio Physics and Electronics, Kolkata, and PhD from Royal Military College of Canada. Dr. Sidhiki is a chair APS Site and APS Art and Coordinator. Can we have your message, sir, please? Over to you, sir.
Thank you so much. No, I'm PhD from Institute of Radio Physics and Electronics, University of Calcutta. I'm the Professor Guha. So I did my postdoc at the Royal Military College of Canada. And I've been associated with the Canadian institution and Professor Antar and Dr. Puta since a long time. And in fact, in Kolkata, we formed the first AP chapter, AP-MTT joint chapter. There was no AP-MTT chapter or rather AP chapter in India before 2004. So we have come a long way, I believe. So on the onset, I say namaste to my friends and colleagues in India and friends and colleagues joining from North America and Europe. I'd like to congratulate my esteemed colleagues and friends in Pune for the formation of this APMTT and EMC joint chapter. I'd also like to thank the distinguished officers, IEEE officers, for the endorsement in the formation of this chapter. I feel that APMTT and EMC joint chapter in Pune was long overdue. The reason I'm saying that is on November 2020, the Giant Meter Wave Radio Telescope, the GMRT, was recognized as the third IEEE milestone in India. GMRT being one of the world's largest and most sensitive radio observatory, in which antenna, microwave components and EMC scientists and engineers had vital roles to play in the building's establishment. So a joint chapter of all these three societies will have a stellar role in nurturing future electromagnetic engineers in the region, and Pune chapter will play a very important role. At the same time, I'm also associated, rather the chair of the site committee of the AP Society. At the same time, we should focus on giving back to the underprivileged section of the society, which basically is a commitment of this site committee. And that is where the site, which stands for the Special Interest Group on Humanitarian Technology, fits in. The APS Site Committee has collaborated with the IEEE Humanitarian Activities Committee and decided to fund projects related to humanitarian technology, where advancement of technology for the benefit of humanity is given preference. So this could be projects related to imparting STEM education, providing sanitation, affordable healthcare in the region. We can fund projects and workshops related to these themes. I must mention the Eureka project envisioned and implemented by Professor G.S. Money, which is an excellent idea. And we had a discussion on this a couple of weeks back. And we feel that this should be propagated globally. And the EPS Committee for Promoting Equality is happy to be a part of this project. So please reach out to us for more collaborations. As Professor Antar said and Dr. Puta said, we are there to help you as a regional coordinator. I'm there to smooth out your collaboration with the IEEE AP Society and the members. You can reach out, the chapter officers can reach out with the proposals, and we will look into it. And I also hope for more membership growth in the region. And that is required for the sustenance of our members, as they are the ambassadors of our societies. So I once again congratulate and my best wishes to all, and thank you very much.
Yeah, thank you very much, sir. Surely we need your support for any HSC activity that we take up, sir, in future. Thank you, sir.
Dr. Anisha Apte, again a Punite, is an engineer at Synergy Microwave, New Jersey, USA, and also the editor of APS COPE column. She is also the coordinator for R1, R6 regions. Ma'am, please, your views.
Namaskar, everyone. This is indeed a moment of great pleasure and privilege for me to be here today. First of all, my heartfelt thank you to all of you at the Pune chapter for this invitation to attend this inauguration function and to share my thoughts. Being born and brought up in Pune, this is indeed a very special moment for me to be part of this inauguration function of this IEEE APS MTT EMC joint chapter in my hometown. Pune has always been called the home of knowledge, or Vidyache Mahir Ghar in my mother tongue, which is Marathi. And Pune is also the land of spiritual and cultural abundance, and hence it is also known as a Punya Nagri, or a divine place. It has also been a land of the many great scholars and social and educational reformers, such as Karve and Phule. Our institute is named Savitribai Phule, so the University of Pune. So we have many social and educational reformers who were especially active in the upliftment of the downtrodden through education, and have contributed significantly towards the empowerment of especially women. And in the present day, again, Pune is continuing this legacy with a large number of educational institutes, as many of you have already mentioned. And it has also become globally known as the hub of technological development and innovation. So some 30 years ago, as an undergraduate student of engineering, IEEE was something that seemed to be some vaguely distant entity existing somewhere far away in the United States. And just that we had some knowledge through the IEEE standards that we studied in our coursework. But just a few years later, while pursuing higher education in the USA, getting involved with the IEEE was just an inherent part of going to the university. One reason may be that with the advancement of technology by the end of the century and the turn of the millennium, the internet had made its way into our everyday lives, and access to online resources and online material had become easier and less expensive. Today, with the all-pervading internet, information and resources have come to our fingertips, and instead of searching for opportunities, we have to choose between the ones that best fit our interests and the availability of time and resources that we have that we can contribute with. And also having the right mentor to steer you in the right and bright direction is just as important as having the proper resources. And personally, I have been very fortunate to have found both. After joining the IEEE family, it has always been the feeling of being in an unfathomable ocean of resources. And it is only, I would say that it is only our limitation as to how much we can take in. Sorry, excuse me. It is only our limitation of how much we can take in, and also the avenues that IEEE has provided through which we can contribute, such as IEEE COPE and SITE in the humanitarian activities. So I'm sure that the Vibrant Pune chapter will definitely bring new projects to address the humanitarian activities. And I once again congratulate on this formation of this chapter and wish you all the very best. Thank you.
Thank you, ma'am, for your valuable words. Now I request Mani sir to please take over.
Yeah, wait 1 minute. We need to address Martha ma'am's message. 1 minute. Martha Mogadam did her PhD in electrical and computer engineering, University of Illinois at Urbana-Champaign. She has made significant contributions in the advancement of radar technologies, microsystems, and sensors. She is distinguished professor at the University of Southern California. She was the past IEEE KPS president 2020. However, due to some unavoidable circumstances, she is not able to join with us today, but she has shared her video message, which I would like to play now.
Greetings to all, and a special good evening to colleagues in the newly established joint APS, MTT-S, and EMC chapter of IEEE in Pune. I'm Martha Mogadam, professor of electrical and computer engineering at the University of Southern California, and the immediate past president of the IEEE Antennas and Propagation Society. I would like to sincerely congratulate you on the establishment of this joint chapter. It's a true pity that we cannot celebrate this occasion in person together. But it's also a blessing that we are still able to get together via this digital platform. This remarkable ability, which now everyone takes for granted, is in itself a testament to the success of just a subset of the technologies developed by the research communities represented by our three sister societies and represented in your joint chapter. We can and should be proud of what our technical community has enabled for the world through decades of research and decades of development. And there's so much more that our community is developing towards noble goals, such as connecting the world, enriching of life around the globe, health and well-being for all, safety and quality of life, and environmental sustainability and security. These are noble goals, and as engineers, we owe our society to address them. As we work towards developing better and more novel solutions for these very challenging problems, we should also keep in mind that not only we are working on them for a better and more equitable world, but also that in the process of doing so, we must use practices and processes to ensure that our work is done in a manner that is inclusive, diverse, and equitable, in equitable teams, in diverse teams. I wish you the very best in solidifying the position of your chapter and in attracting new members, which hopefully will include students and both junior and senior colleagues from both academia and from industry. Please don't hesitate to call on us within the parent societies for help and collaboration. Once again, congratulations.
Thank you, Dr. Martha, for sending your best wishes and message for our newly formed joint chapter. Thank you. Please continue, Priya. 1 minute. Please continue.
Okay. Now I request Mr. Jagdish Chaudhary, Head Special Initiatives, Analytics and Insights at Tata Consultancy Services, Vice Chair at IEEE Pune section, to share his views.
Thank you, and greetings to all. It gives me a great pleasure to share a brief overview of IEEE Pune section. I'll just share my screen.
So 1 minute, I will stop my
Yeah,
screen.
you can stop sharing. Yeah.
Yes, sir. Yes. Yeah. Please go ahead, sir. Please.
Is my screen visible?
Yes, sir.
Yeah.
It is clearly visible.
So see, IEEE Pune section is a part of IEEE Region 10. It is one of the youngest sections in India, established in 2010. It has a small geographical area limited to the city of Pune. While the geographical area is small, it is one of the very vibrant sections in India and Region 10. We have a very healthy mix of student members and professional members. Total membership count is 1,017 professional members and 759 student members. We have around 22 student branches which are extremely active. There are multiple active societies and chapters. We also have active affinity groups, women in engineering and young professionals. As a section, what we've done is to sort of, the approach we have taken is to engage with the members and provide maximum value. That is how we drive the membership growth. So we have had a very stable membership and have won multiple awards with respect to membership and overall. So in line with this approach, what we have done is we have set up some special interest groups, which is also in line with IEEE's mission of advancing technology for humanity. So we have a special interest group for affordable agriculture, which has been operating for last 3-4 years. And we have got great support from IEEE Humanitarian Activities Committee and IEEE Foundation to drive projects. As part of this, we have set up multiple affordable agriculture labs in multiple engineering colleges in Pune and also at some of the project sites. We have set up demo farms. Similarly, looking at the interest and the importance of healthcare during the pandemic, we decided to set up a special interest group for healthcare, and which has also been very active in the last 1 year or so. And there is tremendous sort of involvement and participation of the members even in this group. It is shaping up very well. Then there's a knowledge dissemination contest, Eureka, which is one of our important initiatives of the section. In this, we focus on spreading awareness on science and technology among school children, and this is done in a very unique way. The engineering students go and teach science and technology to the school children, and this program has been sort of operating at a very different level. We have it is kind of institutionalized. For many years it has been running, and we have just to give an example, in 2019 for the validatory event, we had ISRO former ISRO chairman Dr. Kasturi Rangan as our chief guest, just to give you a feel of the kind of scale of the event. The other important initiative which we have is STEM to STEAM. So this is this whole activity was triggered when we had a interaction with eminent scientist Dr. Mashelkar, where he encouraged us to sort of encourage inclusion of liberal arts in STEM education. So keeping this in mind, we are driving different activities. We are very closely working with Kelkar Museum to drive this agenda. And also we are having a very interesting program called ECOM, where we are sort of focusing the importance of multidisciplinary knowledge, and very eminent people have been coming on month after month for this ECOM program. One of the very recent programs is TCS Sustainathon, where we are inviting young minds to unleash their creativity to solve Pune's waste management challenges. So this is being done in a very collaborative manner with partners like Pune Knowledge Cluster, Pune International Center, Pune Municipal Corporation, and others. And there has been a tremendous response to this program. This was launched on the 75th Independence Day, and the finale is expected to happen on 23rd of October. There are a few upcoming events. The flagship conference of IEEE PuneCon 2021, scheduled on between 16 to 9 of December, and then the 2021 IEEE second TEMS-MET conference, again in December, 2nd and 3rd December. So I would encourage maximum participation in these important conferences. Coming to some of the section highlights, as I mentioned, this is one of the youngest sections in the Region 10, and there are we have won multiple awards. We had Outstanding Medium Section Award, Best Membership Growth Award, and also Outstanding Section for Humanitarian Activities. All these awards were at Region 10 level. We are having our flagship conference, PuneCon, as I already mentioned. And in addition to that, there are vibrant student branches, as I mentioned, and there are a whole lot of activities which are being carried out through them as well. There are like smart city hackathons, student fests. There are programs like curriculum design, faculty development programs, field visits, panel discussions, paid workshops, etc. So overall, I think it has been a great journey in doing all these various programs, and we have been getting support also from various stalwarts like Mr. F.C. Kohli, founder of TCS, Dr. Mashelkar, Dr. Vijay Bhatkar, Dr. P.K. Sinha, and others. So with this, I would like to close my presentation and over to the organizers. Thank you.
Yeah. Thank you so much, sir, for your kind message. Thank you. Sir, will you?
Yeah.
Sir.
Hello. Hello.
Jagdish, sir, will you please stop your screen sharing?
Yes, yes, I'm doing that.
Sir, on top, you may see that option, stop screen sharing on the top of your screen. Please check it, sir.
Hello.
Yes, sir.
Screen is visible?
Shri.
Yes, sir.
Just give me a minute.
Sure, sir.
There are many distinguished guests in our presence here. I would like to listen to a couple of them. Dr. Yashwant Gupta is here. He's a director of GMRT, and he personally knows many of the VIPs who have been talked today. Sir, Dr. Gupta, if you are here, can we have your message, please?
Yes, thank you. Can you hear me?
Yeah, please.
Yeah, so thank you for giving me this opportunity to express my views. I am the Center Director at the National Center for Radio Astrophysics, which runs the Giant Meter Wave Radio Telescope, which is one of the largest and most sensitive low-frequency radio astronomy observatory in the world. We use that for carrying out cutting-edge research in astrophysics, but a lot of this is driven by the core technology in different areas, ranging from antennas to RF electronics, to optical fibers, digital signal processing, and so on. And so in that sense, I find this today to be a really historic moment, the inauguration of this new chapter at Pune. And it's something that was really much needed and also well overdue. In fact, I remember discussion about this with IEEE Pune chapter colleagues, including Girish, Khilari, and others, when we had a follow-up joint event organized by IEEE Pune and NCRA to mark the award of the IEEE milestone status to the GMRT, something that Dr. Sidhiki referred to in his speech. And so on behalf of NCRA and specifically the GMRT Observatory, I welcome wholeheartedly this initiative. I see tremendous scope for synergy of activities of this chapter with the work that we pursue at the GMRT. And I really look forward to working closely with IEEE Pune in this area of collaboration so that we can make this a strong and vibrant new chapter in Pune. Thank you so much.
Thank you, Dr. Gupta. Very nice of you. And indeed, IEEE Pune section will be looking forward to working with the GMRT. In fact, personally, I've been connected with GMRT right from the very beginning days when Dr. Anantakrishnan was doing the electromagnetic survey in this area, Pune. I think Dr. Anantakrishnan is also around. Dr. Anantakrishnan, if you are there, can we have your message for a couple of minutes, please?
Okay, thank you. Thank you, Professor Mani.
Thank you.
Can you hear me?
Yeah, please go ahead.
Okay. Yeah, here I am. Well, I wouldn't want to add anything further to what Yashwant has already told about the GMRT, which is a crown and the jewel of science and technology in India. But as the president of the Indian Radio Science Society of the RC India, I'm very delighted that the Pune chapter has brought 3 of the IEEE sections together, societies together. I have seen my friend Yahya giving a message, and I of course know Goutam, who worked with us in GMRT for quite a few years and then went to United States. So I'm very delighted about this coming together of the societies in Pune so that you have a consolidated activity. And we look forward to interacting with this chapter from the Indian Radio Science Society in future for progress in many technology areas. Thank you very much.
Thank you, Dr. Anant. Very nice of you. It's a long time remembrances that are coming together, I'm sure.
Yes.
Thanks, Dr. Goutam and Dr. Gupta and Dr. Ramakrishnan. Now it is for the much awaited moment of listening to Dr. Goutam. Priya, you can take over and hand over. Continue with the process, please.
Ma'am, please go on.
Yes, I will. The screen is visible?
Yes, ma'am.
Yeah. It is my immense pleasure and honor to introduce our today's keynote speaker, Dr. Goutam Chattopadhyay. Goutam Chattopadhyay is a senior scientist at NASA Jet Propulsion Laboratory, California Institute of Technology, a visiting professor at the Division of Physics, Mathematics, and Astronomy at the California Institute of Technology, Pasadena, a Bell Distinguished Visiting Chair Professor at the Indian Institute of Science, Bangalore, India, and adjunct professor at the Indian Institute of Technology, Kharagpur, India. He received the PhD degree. I request all participants to please mute yourself. He received the PhD degree in electrical engineering from the California Institute of Technology, Pasadena in 2000. He is a fellow of IEEE USA and IT India and an IEEE distinguished lecturer. His research interests include microwave, millimeter wave, and terahertz receiver systems and radars, and development of space instruments for the search for life beyond Earth. He has more than 350 publications in international journals and conferences and holds more than 20 patents. He also received more than 35 NASA Technical Achievement and New Technology Invention Awards. He received the IEEE Region 6 Engineer of the Year Award in 2018, Distinguished Alumni Award from the Indian Institute of Engineering, Science and Technology, India in 2017. He was the recipient of the Journal Paper Award in 2020 and 2013 by IEEE Transactions on Terahertz Science and Technology. Best Paper Award for Antenna Design and Applications at the European Antennas and Propagation Conference, UCAP, in 2017. And IEEE Professor S.N. Mitra Memorial Award in 2014.
Today, he plans to talk on Mars landing and related technical challenges, NASA's Jet Propulsion Laboratory, and Space Administration. We will have a question and answer session after his talk, so put down your questions in the chat box below. Thank you so much, sir, for accepting our invitation, and please deliver the keynote talk on today's occasion. Over to you, sir.
Thank you so much. I am really honored and humbled to be here amongst all the luminaries. I'm so glad to see all these known faces. In a way, it feels more like kind of an alumni meet of GMRT and NCR people. I can see Yoshwan Gupta, Anant Krishnan. Pune is very close to my heart because my professional career started in Pune. I actually joined GMRT just out of college, and I was part of the developing team of the GMRT. And then I met my wife there as well in Pune. So, people of Pune, they believe that Pune is the center of the universe. And since my wife is from Pune, so I have to agree with that. So with that, if you can allow me to share my screen, then I will do that.
Sure, sir. Just give me 1 minute. Yeah. Please, sir, go ahead.
So I hope you'll be able to see my screen soon. Can you see my screen?
Yeah. Yes,
Okay.
sir, it is visible.
All right. So when I was approached by Professor Mani and Ajay to talk about, give a talk here, so I was thinking, what can I talk? And this week is the Ganpati week, and in Indian mythology, Lord Ganesha is the epitomizes knowledge. So we thought that I will look in the heaven and talk about something, and IEEE also our job in IEEE is to share the knowledge and experiences. So I thought this might be a good topic to talk about Mars landing and the related technical challenges. That what kind of technical challenges that we face when we try to land and a rover on Mars. So let's get going. So a little bit about NASA and JPL. NASA has a lot of different centers all across the United States. And our center, Jet Propulsion Laboratory, is the largest NASA lab for robotic missions. We are in the west coast of the United States, in Pasadena, California, where I'm sitting right now, not too far from there. And we build all these Mars missions related instruments and the rovers. That's what we develop here. And we have a small group of people that directly works, all of us work together. We call it Sub-millimeter wave advanced technology group. If you look at the faces of these people, you'll realize that they come from all over the world. So one of the things that I believe that one of the reasons for the success of NASA has been the diversity of people and the diversity of thoughts. And as Ajay had mentioned, diversity is very important for IEEE as well. So we are really, all the societies, MTT society, AP society, EMC societies, we are really, looking into that very carefully about the diversity and equity. So we follow that at NASA as well. And our group is, symbolizes that. So let's start with the Big Bang Theory. This is not the Big Bang Theory that you watch on TV, but that they show it at Caltech. But this is the real Big Bang Theory, that our universe started with the Big Bang. That's what we believe. And the age of the universe is about 13.85 billion years. And if you go back, we try to understand what happened. GMRT that that Ishwant mentioned, that also does that. We look back in time and trying to understand how all these things came about. And since this is a AP, MTT, and EMC society, then we mostly deal with electromagnetics. And if we try to go back in time and try to understand what happened at the beginning of the universe in electromagnetics, it turns out that we can go back only up to about 380,000 years after the Big Bang. That's when the first light came out. It's called the cosmic microwave background radiation. And before that, we have to use other methods to understand what happened before that. So we actually developed instrumentation to understand, the creation of this universe and how everything evolved. So one of the things that we do at NASA is that we are trying to understand big science questions. And one of the big science questions we try to understand is, are we alone in this universe? When I give talks, I am asked this question, what I believe, what I think, that are we really alone in this universe? Does life exist outside our own planet Earth? So before I try to answer that question, I just want to make sure that you all understand that we have not found any sign of life anywhere outside our planet Earth. So do not believe what you read on the internet about aliens. So we have not seen any sign of that. So if you actually try to answer that question, if you can do some back of the envelope calculations, you can see that where we are going to go. That in our galaxy, Milky Way galaxy, we have about 100 billion stars in the order of magnitude, and we have about 100 billion galaxies in our universe. If you do your math, you will see that, okay, we have about 10 to the 22 stars in our universe. And then we are finding increasingly that majority of the stars, they have exoplanets, that is, they have planets going around them. And majority of them, not only one, like our own solar system, they have more than one planets going around. So what is the, if you ask yourself this question, what is the probability that we find one such planet in all these trillions of planets outside, that one such planet where conditions are such that life can exist? The answer to that has to be, the probability will be non-zero. And that's what we are actually trying to build instruments, trying to understand, is there life outside? And so far, we have found more than 4,000 exoplanets outside our solar system. And you might ask that why 4,000 when there are trillions and trillions of stars? The reason is we have not really looked too much yet. If you look at on the right representation, that in our own galaxy, Milky Way galaxy, we have looked into only very narrow areas. And the reason for that we do not really have this technology to detect exoplanet that is very far away. So also we are looking very carefully in our own solar system that can there be life. What I will give one or two examples. One of them is Enceladus. You can see here, this one is Enceladus is a moon of Saturn, and using an instrument, Herschel Hi-Fi instrument. Actually, I was involved in developing that instrument here at JPL, that we detected that water is gushing out from a very cold planetary body like Enceladus. So if water is coming out, is a cold body, there has to be some kind of sense, energy inside that planet. And the question that comes, what else is there other than water in that? Can there be life? Can there be organic materials? We are actually planning to build some instruments and plan a mission to go to Enceladus and trying to understand that. Another planetary body is Europa. Europa is a moon of Jupiter. It's a very cold planetary body. It's a lot of ice there, but scientists believe that there is a liquid water ocean underneath the thick ice shell. The thickness of the ice about 15 kilometers to 100 kilometers. So since there is a liquid water ocean, it has to have an energy. It turns out that the mantle, like our own planet Earth, then if there is water, if there is energy, is there life in the liquid water ocean of Europa? NASA is planning a mission to go to Europa, and we'll be going there in 2024. The launch will be happening. It takes 7 years to go to Europa. Then we'll try to find out, what is there any sign of life in those. So there is a lot of interesting thing that we do. We are trying to figure out. In one of the things that we do, many of you know that we actually go to Mars. We keep going back to Mars. This question arises that why do we care about Mars so much? One of the reasons that Mars is our closest neighbor. So it is we can go there, and other side of that other closest neighbor is Venus. But Venus is the surface temperature of Venus is very high, 780 degrees Celsius. So not much survive on the surface at least. So it turns out that Mars actually resembles in our planet Earth in many ways, especially in its early history. So the question that comes that, was Mars ever habitable planet? Was there life on Mars at any point of time? Or is there life on Mars today? So this is the main question we try to answer. And that's why you keep going back to Mars and try to understand. And if, look at these two pictures. These are remarkable. These are from Mars. If you pay close attention to the terrain on this picture, you will realize that we get this kind of terrain only when there is flowing water, which means that one point of time on Mars, there is flowing water. If we go to Mars today, we don't see flowing water. The question is, what happened? Where did that water go? Can it happen to our own planet? And what can we do to prevent that? So these are very important questions to answer, and that's what we are trying to understand. And we need to go there to actually do exploration and find out answers to these questions. So over the years, JPL and NASA, we have been building rovers and sending them to Mars. 1996, we sent to Pathfinder and then Spirit and Opportunity, twin rovers that landed on Mars in 2003, and then Curiosity is much bigger. You can see that how the sizes evolved of they're getting bigger and bigger. 2011 was Curiosity, and then we sent earlier this year Mars rover Perseverance landed. It's a very amazing instrument. It might be one of the most expensive self-driving cars, and then it has a lot of different instruments to to explore Mars. One of the instruments, I'll just let you know, that is called MOXIE. The idea of that instrument is that it captures the carbon dioxide from Martian atmosphere and then converts that to oxygen, so that in future, when the astronauts will go to Mars, they wanted to carry their own oxygen from Earth. So this is amazing. That is working great. We have actually the data coming from there, from the Perseverance, that MOXIE instrument, and we are seeing that it's converting CO2 to oxygen using some electrochemical process, and also that when the oxygen can be used as a propulsion, so we'll be able to use that, the oxygen that we generate, to bring the astronaut back to Earth as well. So there is a lot of exciting thing on Perseverance rover, exciting instruments. So this is the picture of the Perseverance rover just before it was actually packed up and sent for launch. This is in our lab at JPL. Many of you have visited JPL. And if you come here, we'll be able to see this is the high bay where we actually integrate our different instruments and missions. And this is, I'll show you a video of that actually was during the landing of Mars on February 18th. So I hope you can hear the sound. So this is a real-time video where the parachute was deployed.
Has slowed to subsonic speeds and the heat shield has been separated. Tracking maneuver has started. We're 20 meters off the surface. We're getting signals from MRO. Tango Delta. Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
And the voice that you heard is also my colleague Swati Mohan from JPL. And this is the first picture that the rover sent us back. This is amazing. Every time I see, I still get goosebumps. This is amazing technical achievement to land. It's not easy at all to land on Mars. And what you saw there, actually, this is the first time we had video cameras on the rover as well as on the spacecraft. So we took, as it was going down, we were able to take pictures, as well as we had actually Mars Reconnaissance Orbiter, a satellite that is going around Mars, was able to capture some of the landings. So let's get into some of these technical challenges that we face when landing on Mars is not easy. It's extremely challenging. So as a result, we failed many times. People have around the globe, all the different space agencies. It is because it's not easy. So what happens? How do we go there? How do we land? So that's what we'll talk a little bit about. So on July 30th, 2020, the Mars rover Perseverance was launched. At the time, you can see that Mars was about 260 million kilometers away from Earth. So this is the orbit of our planet Earth, the blue orbit around Sun. And the orbit that we took for going to Mars for Perseverance rover is this elliptical orbit. And the cruising speed of the spacecraft is about 77,000 kilometers per hour. You can see this is a huge speed. So we'll have to time everything perfectly, because it turns out that the alignment of Mars and Earth occurs, the best alignment, that is the closest alignment, happens once in 26 months, about once in 2 years. We have about 3 weeks of window. That's when we can launch and arrive at Mars. So it is very critical that we actually launch it in the right way. And then we'll have to arrive there. You can see here that we'll have to arrive, the spacecraft has to arrive at the meeting point just before Mars arrives, because if the timing is little bit off, what will happen is if we arrive little early, then we will miss Mars altogether and we'll take this orbit back. Or if we arrive little early, then Mars will leave us and we won't be able to catch up. So this lot of calculations has to go and everything has to work right. And it happened that way, that we were right. So as I was saying, the hard truth about Mars landing is that there has been a lot of failures. This is the list of all the success and failures of Mars landing. However, over the last few years, last about 20 years, we have been very successful. Last 6 consecutive missions to Mars has been successful, and many of you know that China also landed a rover on Mars, Zhurong, and I am really looking forward. Our ISRO has had the mission Mangalayan, but that was an orbiter, and in future they are also planning a lander. There are a lot of challenges, but I'm sure that we'll be successful in that as well. So again, these are the different successes over the years that we landed on Mars. I mentioned some of them, but last few of them, Spirit, Opportunity, Phoenix, Curiosity, Insight, and 2020 have been all successful. Overall success rate internationally is about 40%. However, as I mentioned, past 20 years, our success rate has improved. It went up to 75%. So we are learning from our, it's called lessons learned. So we are learning more and more, how to do it right. So these are the different locations, all these different missions that we landed, Phoenix, Viking, Pathfinder, Opportunity, and Perseverance rover today. And so how do you do that? What technology, considerations you'll have to, science and technology issues that you'll have to deal with. So landing on Mars is difficult because Mars atmosphere is very thin. It's about 1% of planet Earth. As a result, that when our spacecraft enters Mars atmosphere, we do not get enough drag, enough friction and the drag to slow us down. So we'll have to be really careful how we enter. What we do is that we enter Martian atmosphere at the altitude about about 130 kilometers or so. We enter a specific angle. So from the time it enters Martian atmosphere to the time it lands, we have about 7 minutes to slow us down. So I mentioned our cruising speed is about 77,000 kilometers. However, we slow down just before entering Martian atmosphere to about 20,000 kilometers per hour. But from there, in 7 minutes, we'll have to come to 0 speed. And we do not have that much help from the atmosphere. So what we'll have to do is we'll have to maximize the path length. So we enter at around 11 to 12 degrees. So that is very critical that we enter in that angle. And then about 130 kilometers, above the Martian surface. And then around this location, we feel the maximum G because the deceleration happens about 8 to 14 G that's what we feel. And then we have a parachute because we cannot still slow down enough. We have a parachute that is deployed when we're about 10 kilometers above the surface. And still our speed is very high by then. So it used to happen before that where the landing ellipse, the accuracy of landing is to be about 100 kilometers by 20 kilometers before. However, with the new technology, I'll talk a little bit more about that, about AI and some radar technologies. We are able to land now with that, accuracy of the area is about 10 kilometer diameter. So we are much better nowadays to land where we can. So so let's go through a little bit more about what happens during the landing. So we have a big parachute, 21-meter diameter. We'll have to do a lot of experiments on material science as well, because what kind of material you use so that when the speed is extremely high, but you deploy a parachute, we'll never deploy a parachute at this speed on planet Earth. So parachute diameter is about 21 meters. So it happens about just 12 seconds before touchdown. we actually use also a crane. So it slows us down. The parachute slows us down. However, that is not enough. And then it releases this spacecraft, and it has thruster. You can see the 4 thrusters it has. And then it slows us down, but it cannot go all the way down. You saw in the video that when it's going down, if it is too close, Mars has a lot of boulders on the surface. So if we still have these thrusters going, then all this dust and debris will come up and will destroy our space, the lander. So we cannot do that. So we came up with an idea of space crane. So when it is about 20 meters above the surface of Mars, so we lower the rover using a sky crane. It lowers it down. The cable length is about 20 meters. So that's what happens. And then, as I was mentioning, it turns out that during this landing, we had some problem, in the sense that as the rover was going down, it was landing in a different place, because challenges that we have in Mars, and Mars has a lot of big rocks. So if we don't land on the right spot, if we land on a big rock, and then this spacecraft will go, rover will go belly up. So about $2 billion mission goes down the drain. So we'll have to be really careful. So what we did this time is that we took a lot of pictures around the location that we want to land using MRO. And so those information was fed to this rover during the landing, and using AI technology and the radar, as it was going down, it was taking radar images, it was taking optical images, and just comparing with the stored information that it had. And it turns out that actually it was going off track during the landing, but it actually made those self-correction. We do not have any control at that time, because it takes 13 minutes for light to reach from Mars to Earth. So we cannot really control, online control of the spacecraft. Is all on its own. So it made those self-correction and landed on the right spot. So that was an amazing achievement. And also, we have to have a lot of different technologies, as I was mentioning. One of the technology that we need is the heat shield, because as the spacecraft goes down, it needs a lot of, generates a lot of heat. And we heat shield has to be the biggest and the largest one that we can, but the light. So it weighs about 2.8 tons, the heat shield itself. And there's a lot of new technologies of the material technologies that we use to make sure that it does not destroy what is inside, that is our rover. So it landed, the Perseverance rover landed at a location called the Zero crater. This is the artistic impression. So we believe that there was a big lake in that area at some point of time on Mars, but this is a dry bed now. So one of the main scientific motivation for this mission is to find, was there life on Mars at any point of time? And of course, dry lake bed is a most fertile ground to find if there is sign of life at any point of time. That's why you decided to land there. You can see the path that the rover is going to take. And one of the things that we are doing this time is we are collecting samples from Mars, because we have different instruments to do experiments in the in situ experiments there. However, that is not enough, because not all the experiments you can do. So what we are doing is we are collecting samples from Mars. It's called Mars sample collection. However, we won't be able to bring them back this time. So what we are doing is that we collect drill hole and collect size of chalk, that we write on the blackboard. So that kind of chalk size sample, it will collect and keep it in containers, and they leave it there. So we are planning another mission in 2026 timeframe that will go there and collect all these samples. And then it will launch in put in a container and launch it in the orbit, and it will go around. So that's what we are going to do in 2026. And 2030 timeframe, we'll send another mission that will go and collect that container and bring it back to Earth, and so that we can do more experiments. So this is the first step of some Mars sample collection that we are doing. We already started doing in the first one, sample collection. You must have read in the news that we are not successful, because it turned out that the stone that we are drilling, that was more brittle, so it became all powdery. It was not a chalk. The second try that we had, we were successful. We started collecting samples. And these are some of the pictures that were taken during the landing. This is the first time, as I said, we had cameras and video cameras there. You can see here on the right that the different locations where all these different parts landed when we landed on Mars. And this on the right top, you can see, as I mentioned, MRO, Mars Reconnaissance Orbiter, was going around and taking pictures. It showed that when the parachute was deployed, it was able to capture from the MRO satellite. So we saw that is how it all went down. And then this is the first picture that it sent to us. It is a dusk time. The sun was setting on Mars on the Martian evening. And you can see here that we see for the first time how the terrain looks like where we landed. And then it sent many more pictures. You can see here, as I was mentioning, if we show some of these pictures to someone and tell this is from planet Earth, people will believe. So it is so remarkably similar terrain on Mars from what we see. And then, okay, as I mentioned, this is very challenging. A lot of things has to work. A lot of things has to go right. Each and every one of them. We have 3 sets of batteries, multiple computers, and thousands and thousands of lines of code. We have multi-beam radar, cameras, inertial measurement system. We have 79 explosive devices, including we have a guillotine cutter, because as the sky crane lowers the rover onto the ground, we'll have to cut those cables. We have mortar cannon to launch the parachute. We have thermal tiles, 16 rocket motors. You think about anything, and all of them has to work perfectly to land on Mars. And then our actual scientific experiments start. I actually work building on those scientific experiment instruments. But again, so I was also involved in developing some of the landing radar part. So it is really exhilarating when you see that when you work on something like this and it works, it lands on some other planet. So this is the best feeling that you can get as an engineer, as scientist. So that was the Mars, but this time we did something more. And I'll talk in the next few slides. I'll talk about that. Then I'll end. I'll be able to happy to take questions at that time. So we we flew a helicopter on Mars as well. So one of the questions that what is the motivation behind that? Why do you want to fly a helicopter on Mars? The reason is that, the rover has limited mobility. It cannot really go everywhere and do all these experiments. And we do not know a lot about the terrain as much. So if we have with us a rotorcraft, can be a helicopter, can be a drone, whatever you want to call it, that can have some reconnaissance, some sensors that can take off, go around, fly, and send those information back to the rover. And the rover can analyze, and if it finds something interesting, then it can go there and do the experiment. So that is the idea of flying a helicopter on Mars. So for this was a technology demonstration called Tech Demo. We are not doing any scientific experiments with this. We wanted to show, can we fly a helicopter on Mars? You might ask me that, what's the big deal about flying a helicopter on Mars? We fly helicopter we look up in the LS sky, you see helicopter all the time. What is the big deal? The big deal is, as I mentioned, Martian atmosphere is much lighter, 1% of planet Earth. So when a helicopter flies on Earth, then the rotor blades, rotates about 400 to 600 RPM, revolution per minute. Same helicopter has to rotate, the rotor has to rotate at 2,600 to 3,000 RPM. This is a huge challenge. And if you're trying to fly something really small with that rotation speed, the stability is a big problem. It actually crashes. We have some videos when we first started trying to fly on that speed in Martian environment. In our lab, we created a Martian environment in our lab. It was crashing. Then we actually solved those problems. So these are the idea of this helicopter was that it will fly very short duration, 2 to 3 minutes. And then it can go maximum about 600 meters. It will fly about maximum height. It will go about 40 meters. The reason is if you go beyond 40 meters, we do not have enough thrust, to lift to keep it flying. And one of the advantages is that since it worked on Mars, I'll show some videos, is because it's a lot of applications on planet Earth. We all know that, disaster areas in high altitude, Himalayas, we cannot fly a helicopter for rescue operations. But this technology that we have developed now will be able to actually fly helicopter at this high altitude for rescue operations, for delivery of goods and supplies in disaster areas. So there is a lot of application that is coming up with this. As the total mass of this helicopter is about 1.4 kilograms, and the wingspan of these blades about 1.1 meter, and it has its own solar power, about 220 watts. It is a completely autonomous, fully autonomous vehicle. It has gyroscopes, accelerometer, camera, everything, and then it goes on its own. We have telecommunication. We have some antennas there so that you can send the data back, and so that's what. And then this is the Ingenuity helicopter in our lab just before, again, we integrated that with at the belly of the Perseverance rover. This is an amazing piece of engineering and technology. So once the Perseverance landed, as I mentioned, it was actually mounted under the belly of the rover, and it was covered with a big, this cover. So after it landed, it dropped that cover and then slowly lowered the helicopter onto the ground. You can see here, these are the pictures that is being lowered down. And then it actually lowered on this left panel. You can see here that it's still connected to at the belly. And then it put it on the ground, and the Perseverance rover moved away. You can see that track, marks on that. So this is the first time now this helicopter, or small tiny helicopter, is on its own and on a harsh Martian surface, because Mars has very harsh temperature cycle, about 20 degrees plus 20 degrees to minus 90 degrees Celsius. So it is on it. We didn't know whether it will be able to survive, because we could not do much thermal design around it. So whether it will survive those harsh conditions or not. It's a beautiful picture that shows that our tiny little helicopter is sitting there for the first time on its own. And then on April 19, 2021, it took off for the first time. So what we did, this is on the right panel, what you see is the real altimeter data from the helicopter. And the left, you see the picture, it was taken by the helicopter itself. This is the shadow of the helicopter on the ground. And then the first day, what we did, actually, it took off for about 40 seconds and went about 3 meters altitude and took a turn about 96 degrees. And then it came back down, and it was successful. We flew for the first time a helicopter on another planet. And I'll show you the video of that. So you can see here, this is the helicopter sitting on the ground. The video was taken by Perseverance rover, the mast cam. It was 40 meters, about 60 meters away. You can see here the blades are rotating, and that's where it takes off. You're flying something on another planet for the first time. It made a 96 degrees turn. And then it actually, after 40 seconds, it came back down. So that was the first flight of this helicopter, and we were really thrilled. It was 3 a.m. our Pasadena time when we actually got the data, altimeter data back, saying that, yes, that was a successful flight. So it was an amazing feeling. So what we also did, as an engineer, and as I said, this is a tech demo, you're not doing any science. So we actually trying to break these helicopters. We want to see that where it goes, how far it can go, how fast it can travel before it breaks. We have not been successful yet in breaking it. So I will show you another video, a short video that shows we actually mounted some audio equipment this time onto the Perseverance rover so that we can hear how it feels, what it sounds like when we fly a helicopter. So this is another one that we flew on Mars. You can see here, this is the helicopter sitting there. If you can listen, you will hear the sound of the Martian winds. and there is the helicopter. I'll keep quiet so that you can hear. Then it takes off.
Sir, are you sharing audio also?
Yes, I'm sharing audio, but yes, but you know, this is very low voice, so you won't be able to hear that well.
Okay, sir. Okay, no problem, sir.
Yeah, so you can read, you know, it'll come back, you know, in a few seconds. It went about 80 meters round trip, 40 meters each way. But you cannot hear that well. You know, here I can hear a little bit the rumbling of the wind on Mars. But for the first time, we were able to hear how it sounds on Mars. So you can hear that, you know, frequency is changing as the helicopter is coming back. Unfortunately, it's not loud enough. So it will come back now, and then almost there, it's back. I can hear here, but I'm sorry, I won't be able to hear that much. There it is, that it came back. And then it landed. So it's a remarkable, as I mentioned, it's a remarkable achievement that we have a small group of people were able to build an instrument like this and fly on Martian atmosphere for the first time. So we are looking forward to in future, we will have hopefully many more such flights. And but again, it is extremely challenging to land on Mars and then do this kind of experiments. So it happened because of the ingenuity and the perseverance of the people that have been working on this. That's why the name of the mission, the rover, is called Perseverance, and the name of the helicopter is Ingenuity. With that, I'll end. Thank you very much, and I'll be more than happy to take questions.
It was very great, very great, and very nice, well informative talk. Very nice. Thank you, Dr. Goutam Chattopadhyay.
Yes, sir. After listening your talk, I personally feel that the dream to travel on Mars with loved ones is not far away.
Thank you. Thank you. Yes, indeed.
Dr. Goutam, we are really proud that an Indian is associated. Actually, at least we know one more name, as I said, Swati Mohan. I think we are really proud that on such a mission, Indians have been there and they are able to make their flag fly high. And we are also happy that you could come over here and share those videos, rare videos. I think other people are there to ask questions. I will come back to you again.
Thank you very much. Just I want to mention that it happened because of people from all over the globe. You know, this is a team effort. And of course, you know, we have some Indians who are involved, but, you know, this is, as I mentioned at the beginning, you know, NASA is successful because of the diversity of its, you know, personnel. Thank you.
I also wish to add one point here is that earlier I heard Goutam many times on terahertz technology, and this is the first time I'm hearing about this Mars mission. So it's really inspiring. Congrats for doing such a great job.
Thank you.
Hello, sir. Hello, sir. Sir, I have just two questions, sir. Sir,
yes.
Do space agencies of different countries interact with each other, collaborate with each other for exchanging information?
Yes, absolutely. You know, collaboration is one of the most important aspects of you know, this development, because nowadays the challenges are so big, and cost is really prohibitive. So unless and until we are actually teaming up with different space agencies around the globe, it becomes almost impossible to solve some of this problem. As a result, NASA has been collaborating with ESA, European Space Agency, JAXA, Japanese Space Agency, ISRO. Currently, there is a big mission development going on called NISAR, NASA ISRO SAR, synthetic aperture radar instrument. Only this week when I went to lab, I was meeting some of these ISRO colleagues. They came from Bangalore. They're doing integration stuff. So yes, so collaboration is one of the keys for success. And I can see Ishwant has his hands up. So if Ishwant, go ahead.
Yeah, so since the topic of collaboration came up and you mentioned collaboration between space agencies, there are times when there is collaboration with the radio astronomy community on these exercises. And I was hoping you would talk about the challenge of receiving the weak signals from Mars, especially during the landing phase, where you use your deep space network antennas. And those are very powerful antennas, but that is where sometimes radio astronomy comes to help, because we have some of the most sensitive antennas. And in fact, there was one collaboration that we at GMRT had with NASA and ESA for one of those failed missions that you mentioned, which was the European Space Agency mission. Actually, it was a joint one for both the original InSight, which was supposed to go in 2016 and was cancelled and postponed to 2018, and InSight and the ESA Schiaparelli mission were supposed to go almost together. And we worked with the colleagues from NASA for providing the ground station support using GMRT for this 7 minutes of terror when it descends through the atmosphere. And if I could maybe just take the liberty of sharing my screen for a moment, I can just show you. So this is what happened that time. And as Goutam showed, this is the typical landing sequence with the parachute and the thrusters. And during this sequence, it's hard to get signals to track the fate of how the mission is doing. This is an example where giant antennas of the GMRT were used to pick up the weak signal. It's 3 watts of power being transmitted. So it's almost like you're talking on your mobile phone from Mars, and we can pick up that signal. And that is used to track the health of the mission as it descends. And this, is, for example, is a Doppler of the signal, which is used to track whether it is going as per the plan. And as I mentioned earlier, this was one of the ones that crashed just 40 seconds before the final touchdown. And all of this was being picked up at the GMRT and being relayed to the mission control in Germany. So this is real collaboration, and it's a pleasure to work with the space agencies and get things done, sometimes with the radio astronomers cooperating and collaborating.
Yeah, absolutely. Sometimes, these radio astronomy telescopes are used to, detect faint signals from this universe, but sometimes you can use them as communication, antennas as well. So that's what Ishwant was mentioning. And we do that. And also it's 7 minutes of terror is a real problem for us, because we do not have, line of sight communication at that time directly to the Earth. So in InSight, what we had done as well, that we actually flew 2 CubeSats. It's called, Mars 1. And then we actually communicated, that actually acted as a relay station between the spacecraft to, that CubeSat, and they had X-band antenna beaming directly to the DSN. So yes, a lot of this can be done in future as well. So we are looking forward to the collaborations. I hope that it will grow in the future.
Hello, sir. We have another question, sir. I'm an engineer. I'm a second-year engineer, sir. Electronics engineer. So, sir, we have just listening in the news, and we have seen a science fiction movie which was just a fantasy for most of the people, for writers and the directors in the movies, like traveling to other planets and all. So, sir, what do you think? How soon it will become a reality, and how soon we will be able to do that?
It all depends on you all, your students, how soon you can actually step up to the plate and make new contributions and join ISRO, join NASA, join ESA, wherever you can. So it all depends on you. You are the future for this kind of technological development. So, and of course, you'll have to ask your government to spend more money.
Okay, thank you, sir, for this informative session, and it was really motivating and informative. As a student, I can see very energetic thing in myself to do further and to move further. Thank you, sir.
Absolutely. Thank you. Thank you very much for joining in. As I mentioned, you all are the future. Become an IEEE member.
Yes, so I have a question. How exactly are we going to take the samples of the Mars's rock and take it to the orbit, take it to the the space?
Okay. So yeah, this is a good question. So what happens, what we are doing is that we have a machine there, we drill a hole and collect a sample which is the size of a chalk that I mentioned. And then it actually puts that in a container and it will be leaving it behind on the ground. So we'll be collecting about 40 to 50 such samples from different areas and then leave it back there. So in 2026 mission, we'll have a lander and a rover. The rover will go around and collect all of them and put it in a container, and we'll have a launcher there as well. So you put it in the launch, it will launch from the Martian surface, but you cannot really come back all the way to Earth because then you need much bigger rockets and everything. So this will put it in the orbit around Mars. So it will keep going around Mars. And then when 2030, a mission that we'll have a called Mars sample capture mission. So it will go and capture that container from this Martian orbit and bring it back to Earth. So that's what the plan is. So that's how we'll get those samples back on Earth.
Oh, okay.
Dr. Goutam, if I put it this way, it's probably the longest relay that we'll have. Something like from Mars to the space in probably some 4 years or something, 26 to 30.
Yes, absolutely. The long term, because you'll have to have, you cannot do this, that current technology. Of course, we like to go there, collect everything, bring it back. But current technology does not allow us to do that in a very safe way. And that's why we have to take this kind of relay kind of mission. This is a long-term goal for scientific experiments.
Hello, sir.
Yes.
Sir, due to the thin atmosphere of Mars, so we don't have anything on the surface of Mars. But it is assumed that we can have something underground in the deep down in the Mars. So can't we use the GPR ground penetrating radars to indicate to get some information or something like that?
Yes, we have GPR actually on Martian, these rovers. It is not that we don't have, but it all depends of how far you can go. For GPR, if you think about the two things that is needed. One is lower frequencies, because as you go lower and lower frequencies of penetration is better, and also you need more power. But if you actually if you are going at lower and lower frequencies, then to have a spatial resolution, you need larger and larger antennas. But that is a problem. If you go the huge antenna, we cannot fly. We cannot fly something which needs a huge amount of power. So what we can do with the GPR on Mars to understand what is underneath is somewhat limited because of all these challenges.
Okay, sir. Thank you.
Any other questions?
Yeah, Gautam, just Suresh Kumar here.
Hi, Suresh. Good to see you.
Yeah, nice. Yeah, actually, I have one question. You mentioned about the helicopter used for Himalayan terrain kind of thing. Okay, is there? Can you tell more on that? Is there some collaborations being done on those areas? Because that's a very useful thing, really. These high RPM helicopters for defense applications are really an interesting things, actually, or even for the exploration in Himalayan areas, high altitude areas. So they are interesting areas, actually. Yeah.
Absolutely. We cannot do any collaboration in the defense area. So let me make that very clear first. NASA is a scientific organization. Our collaborations are all scientific and technological.
What about exploration?
Yes, exploration. And that's why this is, as I mentioned, this is a very new technology. We flew it for the first time in April 2021. So it will take some time for this development. And so, but what we can see that these are the applications that we can have. So we are very open about sharing the technology and the knowledge. So I'm sure some companies and also some other countries, people will pick it up and make their own helicopter, and that suits their own terrain and all. So, but we have now a framework, basic framework of technology that will help us to develop this.
Thank you.
Gautam, I have one question. Is it possible in future, can we drill more deeper and deeper in Mars and look at physically?
Yes. So, one of the challenge people ask, I talked to you about the Europa, right? That I said that Europa, there could be life there. If you're talking about Mars, let's talk about a little bit of Europa. That is, ice, thick ice, 15 to 100 kilometers. I ask this when I am giving this kind of talk in person to students. I ask them, suppose NASA comes to you and says that there could be life on the ocean of Europa, but there is a 15 to 100 kilometer thick ice. What kind of instrument you are going to build to actually find out if there is life there? So obvious answer to that is we can send a drill a hole, lower a bucket and see if there is fish. I'm Bengali, I like fish, that's different. But so problem is that it takes about 7 years to go to Europa. It takes 7 months to go to Mars. And total amount of power available to us for this kind of outer planet missions is about 400 watts total DC power. 400 watts is 4 light bulbs, right? So what kind of drill that you can have with 4 light bulb watt of power that can drill 15 kilometers to 100 kilometers? It's not going to happen, right? So we can send a drill, but that drill will not be very powerful because of we do not have enough power and all the mass. Every kilogram of mass that we launch has associated with it about $2 million of cost. So it is cost, it is technology. So hopefully future we'll be able to do that, send bigger drill to drill and see what is going on. But at this point, it's really challenging.
Mm-hmm. Like one question, like suppose you can have some kind of nuclear kind of things, a power generator device there, then perhaps you can drill more.
Okay, nuclear. We are trying to find out if there is life. How do you do a safe nuke? I mean, are you going to destroy? We are either way destroying our own planet in many ways. So it is very, safety is a big issue because we don't want to, 2 things we don't want to do when you're going from another planet. We don't want to carry our own, life from here and detect it there. So, planetary protection is a huge thing. Another thing is that we should not do anything that will have an adverse impact on that. So nuclear power is actually a challenge. So I think there's a hand raised, Suraj Jagtap.
Hello, sir. I would like to ask you about the memory management that is happening on that device.
Can you say it again? Can you say what device you are asking about? I couldn't hear.
The rover, sir.
Rover, exactly. Okay, Perseverance rover. Yes.
Yeah. Perseverance rover, because you are getting a huge amount of data from cameras and different sensors. So how you are managing that data and transmitting it over Earth? Yes,
it's a very good question. Data rate is low. Okay, Mars has bigger antennas. We can, we have 70 meters antennas. This, for the Deep Space Network, 3 of them in Goldstone, California, Madrid, and Canberra. These 3 locations, 120 degrees apart. So we get data and the antenna on the rover is large, but still data rate is much, much lower. So it takes years to actually get all the data down. So that is a big challenge. So we are currently, what we do, the deep space network in X band. However, there has been some push to go to Ka band, that is about 40 gigahertz range, and even optical communication. We are trying to also look into optical communication, but there's some challenges, because optical communication we cannot do when there is cloud cover and everything, but we have demonstrated that optical communication is possible. So in future, maybe a combination of optical communication and Ka or even W band, higher band, so that we have larger bandwidth, will be able to do, so that you can have a satellite up there that collects the data in optical band and then retransmits it back in a higher data rate. So yes, so we'll have, there's a lot of opportunities. If you're a young engineer and thinking what to do, people have already solved most of the problem. That is not the case. So we have a lot of problems to solve. And so you all can step up and, solve those problems. I can see another hand, Mandar and then Tanuj. Mandar, you can go ahead first. I can't hear you if you're speaking. Okay, then we'll go to Tanuj. Can you go ahead and?
Yes, sir. So my name is Tanuj Daryani. So I had a doubt regarding Mars's magnetic field, sir. So I had read it somewhere like the magnetic field of Earth is like around 65,000 nanotesla. And so while comparing it with Mars, so it is 40 times stronger than Mars. So but Mars, so in Mars, so there's no magnetosphere, right? So how did we measure the magnetic field over there?
So yes, that's a good question. We have used some instrument. I don't know all the details about that instrument, how it was measured, but in one of these missions, when it was measured using one of the orbiters. There's some instrument on the orbiters, but I do not know all the details about that instrument. I can check up and let you know, but I don't want to give you a wrong answer because at this I don't know.
Okay, sir. Thank you.
Thank you.
Can I ask a small question?
Hello? Yes, go ahead. I can hear you now.
Yeah. You are talking of the power for drilling machine at the Mars. Are you thinking, as I read sometime, of neutrinos, which can generate the power or which can collect and generate the power? I know this may look an odd question, but I have read about it, that the people are working on those.
Yes,
yeah.
Yes, so I'm aware of those, but one thing is, they're showing that something is possible, but to make something really that will work on the ground, that has not happened yet. So there are a lot of different technologies and a lot of that thing is going on in terms of how to generate more power in a small a small container. Right now, if you think about this Perseverance rover, we do not have solar panels on Perseverance rover. We other missions we used to have solar panels like Spirit and Opportunity, but here we are using RTGs. RTGs is the radioactive thermal devices. So thermal generators. So we use a little bit of plutonium, but again, we'll have to be really, really careful. And also for neutrinos and others, how do you really make a device that will be able to generate the power the way you need it? So those steps we'll have to go. What in our language we call it TRL, technology readiness level. What technology readiness level that is, so that we can actually use it in space.
Thank you, sir.
Dr. Goutam, I understand there is, sorry, am I audible?
Yes, you are. Please go ahead.
There another rover, Curiosity. It is also on their Mars. And what is the role of Perseverance and what is the role of Curiosity?
Yes, so Curiosity was launched, as I mentioned, in 2011. So we always, so far, as one of the slides I've shown, where we landed at each mission has its own scientific, goal, what we want to do. So Curiosity had landed at one place. The type of instruments it had were very different. So here in the Perseverance rover, the main goal of this mission is to find, was Mars ever habitable, sign of life. And then that's why we landed this time in the Zero Crater, which is a dry lake bed. So the instruments on this Perseverance rover is very different from what it was on the Curiosity. So we are, doing the scientific goal is different. The type of experiments we are doing is different from these. Because, think about it. Suppose there is some aliens and they come from some outer planet. They want to know about our planet Earth. So if they land in Sahara Desert, they won't know much. So they'll have to really go to many other places to know about our own planet. So same way, we have only landed in limited areas on Mars because of the limited resources. So that's why we'll have to have different goals in different instruments. So that is the main difference between these two, the type of instrument that we are flying.
Curiosity is still there on the Mars, no?
Yes, it's still there on the Mars. Though, majority of them, like Spirit and Opportunity, is also still there on the Mars. It has gone way beyond its, life expectancy, but it's still, sending data back to us.
Great.
So there's a question from Manoj.
Yes, so namaste. Yes. Sir, my question related to the failed mission. We saw that we have many failed missions. So how we check that what happened to those missions? Like we have many successful missions also. So those rover were able to find those failed rover where that landed, crashed. So have we able to check those things, sir?
Okay, so yes, there, as you have rightly pointed out, there have been failed missions. We try to understand because from the data, whatever data that we got during the descent landing, we collect that and try to understand. However, we cannot send another rover to exactly the same location to find out what happened, because again, when we are doing a mission, we have to do more scientific exploration as well. So most often we try to understand using our orbiters. So, whatever, cameras we have, whatever data that we can collect using the orbiters, looking at the area where the failed mission landed. But sending a rover specifically just to see what happened there is kind of not really practical. So we send rovers to other locations where it's more exciting to do scientific missions. So we move on there as much as we can understand and learn from the data that we get, and then take the next step. That's how it goes. But yes, if it was possible to go back exactly, land there and see what happened, that would have been helpful. Like the way FAA does here and NTSB does here in the US, but we cannot do that on Mars yet.
Okay, thank you, sir. Thank you so much.
I think now we should start thanking Goutam. I think it has been a great evening. I am sure everybody is excited. There will be a lot of questions, I'm sure, but I think there's time to say good things also should come to an end.
Thank you. Thank you very much.
Shall we go on to next item of program?
Yes, sir. Yes, sir. Yes, sir. Yeah. Okay. Now I would request Dr. Ravinder, Vice Chair of Joint Chapter Pune, to express his vote of thanks.
Yeah, thank you, Shri. Good morning and good evening, all the dignitaries. Honorable Shri Girish Khilari, Chair, IEEE Pune Section. Respected Keynote Speaker, Dr. Goutam Chattopadhyay. Guest of Honor, Dr. Bhaiya Antar, Dr. Alistair Duffy, Dr. Rashanda Henderson, Dr. Gray Lyons, Dr. Weng Chiu, Shri Deepak Mathur, Dr. Martha Mogadam, Dr. Ajay Poddar, Dr. Javad Sidhiki, Dr. Anisha Apte, and Executive Committee members of Pune Chapter, Professor G.S. Mani, Professor K.P. Ray, Dr. Shri Kulkarni, Mr. Nikhil Grover, Mr. Pritesh Rathod, all the members of IEEE, our most valued invited guests, ladies and gentlemen. It's my privilege to have been asked to propose a vote of thanks on this occasion. I am Ravinder on behalf of IEEE, AP, MTT, EMC, Joint Chapter Pune, and the entire team. Let me call it as a fraternity of electromagnetics for mankind here together, and on my own behalf, extend a very hearty vote of thanks to all the dignitaries for gracing the inauguration of the Joint Chapter Pune and sharing your opinions and thoughts. I must mention our deep sense of gratitude to all the authorities of IEEE, including Yahya Antar, Dr. Greg Lyons, Dr. Wen Chiu, Dr. Rashanda Henderson, Shri Deepak Mathur, Dr. Martha Mogadam, Dr. Ajay Poddar, Dr. Javed Sidhiki, Dr. Anisha Apte for granting the approval for the Pune chapter. It's a great opportunity for all the IEEE members of Pune to get together on this platform and contribute to the society and research fraternity towards electromagnetics for mankind. Without these people, this chapter would have not been possible. Special thanks are due to Dr. Ajay Poddar, Dr. Javed Sidhiki, Dr. Anisha Apte for continuously motivating us throughout the formation of a new chapter. Further, we are grateful to Shri Girish Khilari, IEEE Chair Pune section for providing the necessary support. I express my heartfelt thanks to Keynote Speaker Dr. Goutam Chattopadhyay for enlightening us on the most exciting topic, Mars landing and related technical challenges. It was really wonderful to hear from a renowned scientist with rich experience in the field. I'm sure that the keynote session has motivated many of us to explore further. Thank you very much, Dr. Chattopadhyay. Special thanks and appreciations are due to our anchors, Dr. Shri Kulkarni and Ms. Priya for coordinating the entire program successfully. We would also like to thank Mr. Jagdish Chowdhury for giving us a crisp presentation about Pune activities. We would also like to acknowledge the student volunteers, Ms. Prajyot, Ms. Nupur, and Mr. Shivraj for their contributions. I fail in my duty if I don't thank all the IEEE members and all others who have directly or indirectly supported us in realizing this chapter and making the inauguration of the same a grand success. Finally, we thank all the dignitaries present over here, the principals, industry and academic experts, the heads of departments and the faculty members and the students from various institutes all over the Maharashtra and across the country for being with us this evening. It's a great pleasure. Thank you. Thank you, everyone. Thank you very much. Over to Jayashree.
Gautam sir, there are so many questions are coming in a chat box. So I request you to make a Pune as a part of your itinerary when you visit to India so that we can have a physical interaction with you.
So any trip to India, I'll have to make Pune as a part of my itinerary. I cannot leave, otherwise I'll have to sleep on my sofa. So.
When are you planning it, Dr. Gautam? Should I ask Mrs. Gautam?
Yes, actually, it's not clear yet because of this pandemic. It's still risky to travel, international travel. So last time I traveled only when my dad was not doing well. So in March, that just before the second wave, I traveled. I'm not sure yet when I'll travel again, but I always, of course, I generally, normal times, I travel 5 to 6 times a year to India.
So Gautam, do you have plans to IMARC in person? Gautam, do you have plan to go IMARC in person in Kanpur this time? You're not.
let's see how things pan out. And
Okay.
decide.
Okay.
That's nice. Excellent. I'm sure, especially I think quite a few students have been attending your talk. I think they will all be quite motivated by your talk. Thanks, Dr. Puta, for all the help. Excellent. I think the way you helped us in many directions, I think it has been really great. Thank you very much.
No, thank you for all, because I think you and I talked before you became, 3 years before you were, I came to your house and then you became sick. And then I thought, okay, all my dream gone. So at least we revived it. Thanks a lot for your support. And it was good sitting in the New Jersey, driving to the IEEE headquarters. Otherwise, normally chapters take at least 8 to 12 weeks to even they listen. So, I personally contacted President Society, and they are very, very supportive. So I wanted to have a record time. So I think your chapter must have been established in record time in IEEE history.
Thank you. Thank you very, very much.
Mani sir, I have disturbed many times to Ajay sir. Every time he guided without his hesitation, and he devoted his a lot of time for my small queries also. Thank you so much, Ajay sir, for this kind of cooperation.
Yeah. Thank you, Dr. Jasri, because I think I saw in Pune a lot of cooperation, coordination, and collaboration. And because I'm leading with around 200 plus chapters, both MTT and AP. And Pune is a very unique, no difference, a lot of good collaboration, and we have lot of future we are expecting from there.
And enthusiasm,
yes, sure,
a lot of enthusiasm especially from Professor Mani.
Thank you.
Professor Mani is right from 1981. DLRL when I joined, he has got the almost same energy.
Oh, thank you.
From 1981, the day when I joined, with the two of us, one Anantalal Das and myself joined. Anantalal Das was working with Professor Mani and I was working with Srivastava. But now I still remember now, after listening to Professor Mani and of course meeting him a couple of years ago in an IEEE events, he is still maintaining. It's very great and it's a God gift, sir.
Oh, thank you.
Thank you.
He has been the very young person for us. He has been inspiring and guiding us. And also we would like to record our gratitude and sincere thanks to Professor Puta and Sidhiki. Even during pandemic time, the sanctioning of this chapter has been on lightning speed. So thank you.
Yeah.
This year has been really great for Pune section, I must say. This is Girish. Yeah, so we started with this JMRT milestone, and then now we are almost reaching towards the end of the year with these 3 chapters. So this particular chapter with 3 societies. So this is started on high note and it is ending on high note. So I'm very, very happy actually.
Thank you, Girish, for all the help. Thank you very, very much. Very nice of you. I think Deepak Mathur has left because he has another meeting going on. So that's why he just came for that 15-20 minutes and then left immediately. I know that.
Yeah, Deepak left me a message, long-time friend. So I was contacting him. He said he could have continued because so much conflicting meeting and going on. And my special thanks goes to Professor Yahya Antar. His generous support for APS Society, even it's collaborative MTT and all the times and anything you need, financial, technical, know-how, workshop, zero bureaucracy. So I want to thank Professor Yahya Antar looking after our society very well, nice way.
I was looking, I was looking for him. I think he seemed to have left because I was looking for him. He seems to have left.
No, I think he's there. He's still there.
Thank you very much.
Yeah, he has left.
Oh, hello,
yes.
Thank you very much for all the help, sir. Yahya, sir, I think it was a great help from you, and without your push, we could not have been where we are today. Thank you very, very much.
It's all your effort and the Jay's effort. I haven't done anything, so you are the leader. So thank you very much for helping with that. That's great for everybody. Thank you.
We will be looking forward for your visit to Pune.
Yes.
Maybe next year.
We are waiting to welcome all of you to Pune, and especially Gautamji, we are really looking forward to have this face-to-face interaction. And thank you for enlightening us today with your candid presentation. It was really, really nice, actually. So we all are thrilled, okay, here in Pune.
Thank you.
Dr. Goutam, are there?
Yes, I'm still here.
Oh, okay.
I'm hungry for breakfast, but still here.
You need to go back to sleep.
A small question. I don't know would like to answer or not. That's why I didn't put it in the event. The general public was there. I was asking you about the perseverance and then curiosity. And after that, the Chinese rover is also roaming around. Any idea what they are doing? Because you told me what perseverance has been doing, what curiosity has been doing. Any idea of what the Chinese are doing?
I don't really, but I'm sure they are going to, publish the findings soon, because the international science community is a kind of they're all joined together. So I'm sure the Chinese scientists, when they find new data, they will be sharing with all of us. So that's what we are looking for. But what I heard that they're actually doing very well. They landed very well. They started doing experiments. So again, we are all together on this. So it is not about any nation. So science actually binds everyone together. So it is.
It's like at IEEE, right? So we all are together.
Exactly.
Very well said, sir.
Another interesting Google News which I saw. I don't know how far it's true. This because according to that Google News, NASA people never thought of recording audio. Most of the time they were thinking of only video. And some chap, some music, somebody connected with the music, he came out with the idea, why not to record audio? This is what some news came. I don't know how far it's true, but it just occurred to me that he is a guy, somewhere, I think, some choir group. He came around and said, why not we have some sort of a audio recording? And that's how the whole thing started, that helicopter buzzing sound. Is there any amount of truth there likely to be there?
Always you'll have to take with a grain of salt of this kind of news, but it is true that we have some young professionals, like that's why you keep talking at IEEE also young professionals. They decided they actually got some off-the-shelf cameras, video cameras and audio, and put them on the rover as well as on all the different spacecraft, and we are able to capture all these videos. And we didn't know that all of them will survive, because as you know, for space we'll have to go through these different thermal vac and all off-the-shelf components. It doesn't work. It turns out that except for one camera, all of them work very well. So because of these young professionals, so that's why we are very much excited to have so many young professionals in this forum.
I think there are quite a few young professionals in this must be here. I hope they are listening.
And also young professionals like Professor Anand Krishnan, you and everyone else.
Right.
Yes. Thank you. I remember when first I met Dr. Anand, that was must have been somewhere in 1992. Maybe I'm not sure. I had just come to Pune. I was in Hyderabad. I had come to Pune, and one day he landed up, and I didn't know who was Anand Krishnan. I didn't know even GMRT at that time, because I knew OT telescope. So he introduced me himself and said, this is what we want to do. And of course, I just about 5 minutes earlier to that, I was heading the electronics department at IIT. And our director rang me up and said, there's somebody coming from OT telescope. I said, fine, OT telescope, I only heard, I never met anybody from there. But when Anand rang it up, and he said he's from GMRT. He's a different guy. I don't know why he is standing here. That's what I first asked. Of course, when he told me his background, then I said we became close chums. I think that's how we have been together for the past almost 20, 25 years now. And at that time, we had some sensitive equipment for my EMC equipment with us. And they wanted to make the sort of a survey, RF survey of the whole area. So that is where I think we got together. Antar was very good on that subject and he is around. That's how my first interaction with GMRT. Later on, of course, Dr. Govind Swarup, I've been taking my students to him and he has been advising us on many counts. He has been great. He was great. And nice to know, I didn't know that Goutam belonged to Pune. Let me know come on the first name terms. That's great. Nice to know so many people here connected with Pune in some form or other, like Ajay Puta, yourself, even Yahya had visited Pune. Am I right, Dr. Antar?
No, I never got the chance yet, unfortunately.
Okay.
So
I think. So next time you should definitely make it. There's one more reason why you should make it to this place.
I will definitely look forward to that.
Okay.
Thank you.
Thank you, sir.
Yeah.
Right, Ajay, take leave.
Thank
Okay,
you.
thank you.
Yeah.
Thank you. Thank you.
Thank you.
I met you in Atlanta. Goutam, thank you. Nice lecture in a way. I think this is the one I could,